Hey everyone, welcome back to the APIGURU channel. If you're new here, I'm Damien Tone here, and on this channel we cover everything you need to know about APIs, integrations, and modern API management. In today's video, I'll show you the difference between function calling and the model context protocol by using both for the same AI agent. Before we jump into the demo, let's take a quick look at the architecture. We will be using an AI agent built with the Google Agent Development Kit, or ADK. The agent uses the Gemini 3.1 Flash Lite model and interacts with the customer service to retrieve, create, update, and delete customer information. Rather than allowing the agent to communicate directly with these services, every request is routed through Apigee. Apigee sits between the AI agent and every backend system, governing and securing every interaction. It protects the Gemini model endpoint, the customer REST API, and the MCP endpoint using OAuth 2. It also exposes the customer REST API as MCP tools using the Apigee MCP discovery template. We'll start by demonstrating traditional function calling, in which the agent invokes REST API operations via Python functions registered in the agent's context. Then we'll switch to the Model Context Protocol, or MCP. Instead of manually defining those functions, the agent will dynamically discover the available tools from the MCP endpoint at startup, making the integration far more scalable and easier to maintain. The customer API is intentionally simple. It's a REST API that exposes operations such as listing customers or retrieving customer details. Nothing unusual, just a standard enterprise REST API. Let's start with the traditional approach, function calling. With function calling, every API operation must be wrapped in a separate Python function. For this demo, I've created two functions, one to list customers and another to retrieve a specific customer's details. Each function includes metadata that describes what it does, the parameters it accepts, and the values it returns. These functions must then be manually registered in the agent's context. When the agent starts, it already knows about these tools because they were defined during development. Based on the user's prompt, the model inspects the available tools, selects the most appropriate one, and instructs the agent to execute it. Let's see how that works in practice. I'll ask the agent, can you list all customers? The model decides it needs the list customers function. The agent executes that Python function. The function calls the customer REST API through Apigee. Apigee validates the OAuth token. Apigee forwards the request. The response comes back. The model formats the answer. Simple. Now let's ask, what are the contact details of John? This time the model decides it needs the get customer details function. The agent executes it. Apigee protects the API. The backend returns the data. The model generates a natural language response. Everything works perfectly. So, what's the problem? The issue isn't functionality, it's maintenance. Every time your backend team adds a new REST endpoint, someone must write another Python function, someone must describe the parameters, someone must register it with the agent, and someone must test and redeploy the application. If you have 20 APIs, maybe that's acceptable. However, if you have hundreds or thousands, maintaining function definitions quickly becomes a nightmare. The agent only knows about the functions that were compiled into it. Nothing is discovered dynamically, and that's exactly the problem MCP solves. Now let's look at the same application, except this time, instead of manually registering functions, we'll let the agent discover them automatically. Everything in the architecture stays the same. Same AI agent, same Gemini model, same customer API, same OAuth security, same Apigee platform. The only thing that changes is how the tools become available and how we call the functions. Instead of manually creating Python functions, I've exposed the customer REST API as customer MCP tools using the Apigee MCP discovery template. No custom MCP server is required, no manual tool definitions. The REST API already knows its operations. Apigee simply exposes those operations as MCP tools, translating tool requests into REST API calls and converting the responses back again. If you'd like to see this in action, check out our next video, where we'll demonstrate how to transform any REST API into secure MCP tools with Apigee. Now watch what happens when the agent starts. Instead of loading a hard-coded list of functions, the agent connects to the MCP endpoint. Apigee authenticates the request. The agent performs MCP discovery. The MCP endpoint returns the available tools. The model now knows exactly what capabilities are available. No manual registration, no duplicated definitions, no code generation. Everything happens dynamically. Let's enter the same questions again. List all customers. This time, the model doesn't use locally registered functions. Instead, it invokes an MCP tool. The MCP server calls the same REST API through Apigee. The response comes back. The answer is identical. Now let's retrieve a specific customer's details. Again, the same user experience. The difference isn't visible to the user, it's visible to the developers. Now imagine your backend team adds 10 new endpoints tomorrow. With function calling, you need to update the Python code, add new function definitions, register new tools, test everything, redeploy the application. With MCP, nothing changes inside the agent. The next time the agent starts, it performs discovery again. The new tools automatically become available, no application changes, no redeployment, no duplicated work. This is exactly why MCP is becoming the standard protocol for AI tool integration. MCP supports real-time tool notifications. However, Apigee's managed MCP endpoints do not currently emit tool list change events over SSE, requiring agents to reconnect or restart to discover new tools. Let me show it. Right now, the MCP product in Apigee only allows access to two operations as tools: list customers and get customer details. Let's change that. I'll open the MCP API product in Apigee and enable one additional operation: create customer. That's the only change I'm going to make. I won't modify the agent, write any Python code, or register a new function. Now let's restart the agent and submit another prompt. During startup, the agent performs MCP discovery again. This time the MCP returns the updated list of available tools. As you can see, create customer is now automatically available to the agent. No code changes, no manual function registration. The agent simply discovers the new capability through MCP. So what have we learned? Function calling is a simple and effective approach when you're working with a small number of tools that rarely change. But as your API landscape grows, maintaining those tool definitions quickly becomes a challenge. MCP takes a different approach. Instead of hard-coding tools into the agent discovers them dynamically at startup. This makes AI applications easier to maintain, more scalable, and better suited for enterprise environments where APIs are constantly evolving. If you'd like to see how I expose the REST API running on Apigee as MCP tools using the Apigee MCP discovery template, be sure to watch my video Turn any REST API into secure MCP tools with Apigee. It walks through the complete implementation step by step. If you enjoyed this video, please like, subscribe, and let me know in the comments whether you're using function calling, MCP, or both in your AI applications. Thanks for watching, and I'll see you in the next video.